Unit 4 is kind of piggybacking off of what we just did Unit 3. Unit 4 is just taking the quadratics and bumping it up to many other polynomials. A polynomial is anything with a whole number exponent or basically a real coefficient. So, for example, if let's get one. I'll come up with an example of one that is and one that's not. So, when it comes to one that is, all the stuff we just got done doing, so x to the fourth power plus 3x squared. Okay, that is example of not would be this. You go x to the negative third power. Because of the negative 3, I don't have a whole number exponent. Or I could have like 5ix squared, because that right there is not a real number. That means that wouldn't be a polynomial either. The degree is the largest exponent, and the leading coefficient is the number in front of the first term when put into standard form. Okay, so some polynomial vocab. You can name the polynomial by degree. So 0 would mean that it is a constant. So example, me just putting down the number 5, that's a constant. If it's to the first power, it's linear, and you can pick whatever variable you want. But if I go 4 and then x, that's really x to the first power, so it's a line linear. 2, we just got done doing a lot, that's a quadratic. So 5x squared plus 3x. That's the highest power, so that's the degree I go off of. Cubic for the third power, so x to the third plus 2x squared plus 1. Okay, again, go with the highest exponent. And the last one that's really of note is going to be a quartic. That's to the fourth power, so x to the fourth. If it's 5, we'll just go, it's a 5th degree. If it's 6, 6th degree, 7, 7th degree, and so forth. Another way to name the type is the number of terms. And what I mean by terms is if I have just one thing, like 5x, is called a monomial. If I have a plus in between the 5 and the x, now it's 2 terms, so it is a binomial. If I put in a third one, lefty issues, so 1, 2, 3, it's a trinomial. If it is 4, so like x to the third plus 2x squared plus x minus 5, we'll just call that a polynomial. Okay, so is this a polynomial or not? So not a polynomial because of that negative 2. This one is, because 3, 4, and there's no variable on the last one, is perfectly fine. I'm going to put this in a standard form. So x to the fourth would go first, then x to the third and the 0.8 in front of it, and then a minus 5. Okay, that is the highest degree. Okay, so it's a 4th degree, or you could call it a quartic. The leading coefficient is that 1 right in front of there. Okay, now leading coefficient and the degree are going to be very big here in a second. Okay, so here we go. We'll talk about the standard form. So I'm going to go with square root 2 x to the third plus 3x squared plus 4x. The leading coefficient is that number right there, the square root of 2, and it is a 3rd degree. Now I can call that a cubic because of that 3rd degree. So in fact, I'll even call it a cubic because of the number of terms. It's a trinomial. And we can focus on those a little bit more as we get going, as we get our answers. I'll kind of ask you those things to make sure that you kind of understand that that's what those things are. Now, end behavior. Okay, I'm going to start off with x to the first. This is a line. I know my graph paper is not the greatest, but it would go just like that. It's got a y-intercept of 0, a slope of 1. Okay, now in terms of end behavior, what I'm interested in is what happens on the positive side of the x-axis. So this x arrow and then infinity really means this part of my x-axis. So that's your x approaches infinity. the f of x would be what happens as it increases. So ours goes up, so ours would approach positive infinity. This negative infinity thing means you're over here, so x negative infinity. So really it's asking what's happening on the right side of the x-axis, what's happening on the left side of the axis. It's either going up, and in this case, on the negative side of things, it is going down. So we would go to negative infinity. I'll come back to the one over there. Okay, x to the second power. So x to the second power, here's your general parabola. So here as x approaches infinity, it's going up. So infinity. X approaches negative infinity, it's also going up. So it's approaching infinity. Okay, x to the third. Here's a graph of x to the third real quick. Okay, so x is approaching infinity. So on the right side of the graph, it is going up. But this time on the left side of the graph, it is going down. X to the fourth. Both of them are going up, so infinity for both of them. Okay, and as you look through, fourth power looked a lot like the second power. So what I could say is that if I've got even degree, my end behavior is going to look like this. So on the right side of the x-axis, f of x goes up. On the left side of the y-axis, the graph also goes up. So up and up. Where it's x to the third, which is odd, and even though it's not written x to the first, which is also odd, it's going up on the right side. So on the right side, function is going up. On the left side, the function is going down. Okay, so there's my rule for, I got to look at the degree, and then I've got to look for this. If I put a negative in front of x, here, I'll maybe do this in another color. Let's go purple. It's going to look something like that. It's going to go down with a negative slope. So now it kind of flip-flops. Now it's going down on the right side and up on there. Negative x squared, so it's similar parabola, but now it's opening down, so both are going down and down. Okay. Oops, horrible graph, sorry guys. But on the right side over here, it's going down, and on the left side, it's going up. And x to the fourth, it is going to go down and down. So I'll have to not only look at the degree, but even degree, odd degree, I need to also look at the LC, the leading coefficient. Because now my f of x, it's going to go on up, down and down when it's even. Instead of going up first, it's going down on the right side, and it's going up on the left. So basically a big old reflection on the x-axis. So here is how I end up using my end behavior. Okay, I look for the highest power. So there's my leading coefficient and its highest power. So I'm going to start off by looking at the exponent first, and that's going to go up and up. Okay, because that guy right there is a negative, it's going to reflect over that x-axis. So on the left, I'm going to go up, and on the right, I'm going to go down. Make sure you grab the highest degree. So there we go. I'm going to go up and down like this because of the 5. It's a positive 2, so nothing's going to change. So on the right, it's going up, and on the left, it's going down. Okay, even power, so kind of like a parabola, up and up. But because of that negative, it's reflected, so it's down and down. Okay, x to the second, again, looks like a parabola. Because of that 4, it's going to stay going up and up. So where that's going to help me is eventually when we graph something like this, we get to that third power. Here's my end behavior. So I know that this side's going to go up, this side's going to go down. All this other stuff along with some table work is kind of what's going to tell me in here. But we're really just focusing in on what the ends do, hence it's called end behavior.